Previously, we talked about how to simplify a rational expression. Comparing the process to simplifying a fraction, we can see they follow the same 3 steps. First step is to factor the numerator and the denominator. So in this case, we factor 18 as 2 times 3 times 3 and 10 as 2 times 5. So we do exactly the same thing, except that factoring a polynomial is more difficult than factoring a number. So first we factor out the GCF, negative x, and then we factor the trinomial as x plus 3 times 5x minus 4. And similarly, we can factor the bottom as 3 factors, x times 2x plus 3 times 5x minus 4. And the second step, we cancel the common factors. And the important thing is we can only cancel factors. We cannot cancel any terms. So in this case, we can find 2 as a common factor. We can cancel them. And similarly, we have 5x minus 4, 5x minus 4 as a common factor. Notice that whenever we call factor, the operation has to be multiplication. And that's exactly the proctoring process is. So we have the answer. We can multiply out. We can also cross out x as another common factor. And again, because it's multiplication, x is a factor. And so we cancel all the common factors we can find. And the last step, we can multiply the factors left. So the top times top, we got 9. And the bottom, there's only 1 factor left. We just keep it. And similarly, we have 1 factor, 2x plus 3 left. And the top, we multiply negative with the x plus 3 to get negative x minus 3. So comparing these 2 types of questions, although a rational expression is much more complicated than a fraction because it has numbers and variables, and the process, as we can see, simplifying a fraction and simplifying a rational expression is very much similar. So today we're going to talk about how to multiply or divide two rational expressions. So similarly, we can compare the process to multiplying 2 fractions. So this is the question we reviewed before. When we have 2 fractions, we can multiply straight across 9 times 10 and 35 times 21. So in this case, we can do exactly the same thing. Because rational expressions are pretty much just like fractions, except we have variables in there. We can also follow the same rule, multiply straight across. So we have 4a times 9ab times 10b cubed. In this case, we're multiplying 3 rational expressions. And bottom, we have 6a squared b squared times 12a squared times 15a. In the next step, we want to cancel the common factors. There are 2 possible ways we discussed before. The first way is we can multiply them out. 9 times 10 is 90, and 35 times 21, you might have to use a calculator or multiply vertically to get the answer. Takes a little bit of time. And we have to make sure we reduce this, divide by 5, because one of the ends in 0, the other ends in 5. We know 5 should go into both numbers. So we have 18 in the first case. And the bottom, we have, after we divide by 5, we should get 147. And next, we can see if we can factor this any further. And notice that 3 goes into 18, and 3 also goes into 147 because adding all the digits, 1 plus 4 plus 7, it gives us 12. And that's one of the rules we learned before during the first week. If 3 goes into the sum of all the digits, then 3 should go into this number. So we know for sure 3 goes into both of them. So we can divide both of them by 3 to get 6 and the bottom we have 49. And notice that 40, the only number that can go into 49 is 7, and 7 doesn't go into 6. So this is one possible way to do it. But notice that when we are checking for a common factor, a number that goes into both top and bottom, this can be done by the other process, which is factoring. So instead of doing this way, I could factor all the numbers here without multiplying them. So for example, 9, I can factor it as 3 times 3. 10, I can factor it as 2 times 5. And in the numerator, the two factors we have 35 can be factored as 5 times 7 and 21 as 3 times 7. So instead of multiplying out and try to figure out what numbers can go into both top and bottom, I can factor each numbers and look for the common factors. As we can see here, we found that 5, there's a top 5 and a bottom 5. They top and the bottom numerator and denominator have a common factor 5. This corresponds to the first step we did right here to divide both numbers by 5. So after we can cross them out. It's equivalent to dividing both numbers by 5. And secondly, we also saw there's a top 3, bottom 3. It doesn't matter which 3 we cancel. So let's just cancel this 3 and that 3 on the bottom. So that corresponds to the process of dividing both numbers by 3. After we cancel all the common factors, as you can see, the top we have 3, a factor 3, and a factor 2. But the bottom doesn't have 3 or 2 anymore. And the bottom has 7 and top doesn't have 7. So which tells us there are no more factors, common factors. And we can now multiply straight across. So 3 times 2 is 6, 7 times 7 is 49. And I think this process is quicker than the process we did, multiplying the numbers to get two big numbers, and we have to reduce them all the way down to a small, a reduced fraction. So this is going to be the process we're going to use to simplify, to multiply rational expressions. Okay, so the first step, I multiply the straight across, top times top, bottom times bottom. That's what I got. And for the variables, so there are two different ways we can do. We can go ahead and cross them out. Say A, there's a top A cancels this bottom A here. We can do that. And then we see there's another A here that can cancel one of the A's here. And the B cancels that B. And so it's possible to do that. But it is a little bit messy. So one of the ways we could do is, first I'm going to separate put the numbers all together. So 4 times 9 times 10 and 6 times 12 times 15. So all I'm doing here is to use the commutative property of multiplication, just to switch. So I can put 9, 4, 9, 10 together and the 6, 12, 15 together. And then I'm going to multiply out all the variables. I can go ahead and just copy down the variable. A times A, which gives us A squared. And B times B cubed, that gives us B to the 4th. In the denominator, we have A squared times A squared times A. That gives us A to the 5th. So that's something we learned before the first exam. So we can add exponents if they have the same base. 2 plus 2 plus 1, that's A to the 5th. And for B squared, that's the only term. So now it just looks better than what we had previously, because previously we have so many A's and so many B's everywhere. After we multiply them, you will only see one A factor, A squared, and one B factor, B 4th. So that's going to make things a little easier for us to cross out. So now let's work on the numbers. So for numbers, we can reduce them as we did it before. So what we can do is we see that 4 and 6, or 4 and 12. So either way, if you want to reduce 4 and 12, that will give us 4 goes into 12 3 times. So it's like dividing both top and bottom by 4. And 6 and 9 because 3 goes into both of them, so I can divide both by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And also notice 10 to 15, 5 goes into both of them, so I divide both numbers by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. And we still see a top 3 and a bottom 3 a common factor, and a top 2 and a bottom 2. We can cancel all of them out. And so the only number that's left is a top 1 and a bottom 3. And so let's write down top 1 and bottom 3. That's all the work with the numbers. Now we look at the variables, a squared, a fifth, and notice that the top has 2 a's, bottom has 5 a's, and we can cross out both 2 of them. So we cross out a squared, and if we cross out 2 of them, that will leave us 3 of them. So if you have trouble seeing that, what you could do is to expand them. The top has a and a, the bottom has 5 copies of a, and we cross out 2 of them. That just leaves us 3 copies of a, which is a to the third in the denominator. And similarly, b fourth and b squared, we can cross out 2 copies of them, and leaves us a b squared in the numerator. So that would be the final answer. That 1 there can be omitted. So we have b squared on the top and 3a cubed in the denominator. The other way to do the problem, like I said at the very beginning, so I'm going to rewrite it here. A different way to do it is we could go ahead and reduce. So without changing anything, you could keep it as it is and try to reduce this way. The only this is going to work. The only problem with this solution is it's going to look a little messy, not as neat as this one. After you put all the numbers together and multiply all the a's and multiply all the b's, and it will look easier. So we could just go ahead and reduce this 4 and this 12 to 3. And these 2, we can reduce, divide both of them by 3 to get 2 and 3. And then we can cross out 3's. And 10 to 15, we can divide both of them by 5 and cancel 2 out. And so it's kind of difficult to see. And also, we can cross out this a with that a, and one of the a's with the a square here. That leaves us another a. And the b, cross out one of the b's here, leaves us a b. So now we can copy what's left. In the denominator, this is gone, this is gone, this is gone, this is gone, and this is gone. And that is also reduced. And so the only thing left is b third. In the denominator, we have a, b, and there's a squared, and there's also 3. And that's all. And then we can multiply a and a squared, that's a third. And there's also, oh, I'm sorry, this b actually can reduce one of them here to a b squared. So that instead of having b third, we should have b squared. So that b is reduced. So now we have a times a squared, it's a third, and there's times a 3. So that would be the same answer. But as you can see, it's just a little messy, like what the mistake I just made. I forgot that this b can actually reduce that another b there. It's just not very easy to see which one cancels which one. Probably only person who can see that is yourself. And maybe after after you finished it, you probably yourself already forgot which one reduces which one. So that's a small problem with the reducing this way without reorganize everything.